Good morning, friends. Mrs. McBride coming to you straight from my kitchen table. Hopefully you watched the last video, taking a look at parallel circuits. What you need right now is your calculator, your green sheet, and your notes. I'm here on page 11, okay, talking about parallel circuits. Here's a quick joke. When is a noodle a fake? When it's an impasta. Get it? I know, these jokes are great. I can't wait. I can't believe it. All right, so let's first write a definition of parallel circuits. This is a circuit in which current can take multiple paths. Okay, I'm going to skip the equations for a second here, and I'm going to draw a parallel circuit with 3 resistors, a battery, an ammeter measuring the total current, now that's important here, and a voltmeter measuring the voltage of one resistor. Okay, go ahead and stop the video here and see if you can do this on your own. Does yours look something like mine? Now remember, you can put your ammeter here or you can put your ammeter here. And then I just picked this resistor to put the voltmeter around, but if you put it around any of the other ones, that's completely fine too. All right, now why is this a parallel circuit? Well, that's because when current comes out of the battery, it can go different ways. I always like to take my fingers here and trace the path, okay? So if my fingers can split and go different ways, that's what tells me it's a parallel circuit, right? So if you think about it, people from this circuit can go down different checkout lanes. Okay, so one person might take this path, and one person might take this path, and one person might take this path. That's what makes it a parallel circuit, because you can go in different directions. It's not just one path, okay? Now, in the last video, you should have learned some equations. There's a couple of things. First of all, what is the same in a parallel circuit? I hope you were all saying the voltage. So the total voltage is the same as the voltage that goes through each individual piece. We can also say that the current adds up. Excuse me. So the total current is equal to the current through one piece, plus the current through the second piece, plus the current through the third piece, and so on. And again, that's the exact opposite of what's happening in a series circuit. All right, now we had 2 other equations, one for the resistance and one, our fancy version of Ohm's law, VT equals IT times REQ. Now that one's still good, so I'm still gonna write that over here, that VT equals IT times REQ. That one can be used still. Now for the resistance, this becomes a little more complicated. It's 1 over REQ equals 1 over R1 plus 1 over R2 plus 1 over R3, etc. Hopefully this looks a little bit like our equation 1 over F equals 1 over psi plus 1 over so. And just a reminder that we can't say, looking at this equation, that REQ equals R1 plus R2 plus R3. Remember, that's not how math works, and that's a common mistake that people make. All right, now on your green sheet, which hopefully you have, I just want to go ahead and add these 4 equations into this spot where it says parallel resistors. So I'm going to start by writing out VT equals V1 equals V2 equals V3. And then I'm going to do that IT equals I1 plus I2 plus I3. And I'm going to write very smallly that 1 over REQ equals 1 over R1 plus 1 over R2 plus 1 over R3. And last but not least, VT equals IT times REQ. Okay. Let's do some practice problems. Here we go. I've got two practice problems for you today. Now the first one is a parallel circuit here that has two resistors. The first resistor has a value of 4 ohms, the second one has a value of 2 ohms, and the battery has a voltage of 12 volts, just making sure you can see that. Now it asks a couple of questions here. It wants us to find what is the equivalent resistance. It also wants us to calculate the total current in the circuit and the current across the 4 ohm resistor. Okay, so the first thing let's do is let's find the equivalent resistance. So we have to use our equation over here. Well, I guess the question is, what equation would you like to use? Would you like to use this one, or would you like to use this one? I hope you're saying to yourself, we can't use this one because we don't have the total current, so we get to use this one. So let's do 1 over Req equals 1 over R1, which is 4, plus 1 over R2, which is 2. Now this is nice because we can probably do this math in our head. Everybody here can probably say, what is 1/4 plus 1/2? Okay? Hopefully you're saying 3/4. Now that's still not the answer, right? Because in order to solve for Req, we need to find the inverse of this. Now, however you want to math this, I sort of like cross multiply, or you could easily flip both fractions and get that Req over 1 is equal to 4/3 ohms. Okay? Now, how do you know if you're right? Req is always smaller than the smallest resistor. Okay, so here my smallest resistor is 2. 4/3 or 1 1/3 is smaller than 2, so I know that I'm right. Now the next thing it wants us to do is it wants us to calculate the total current in the circuit. Okay, so there's two different ways to calculate the total current in the circuit. We could either use this one where we add up all the currents, or that one. What are you thinking? Hopefully you're saying that one. We can't use this one because we don't know what the current is through each piece. But we can use this one because now we have both VT and Req. So let's take a look at what this looks like. If we use VT equals IT times Req, the total voltage from the battery is 12. The total current we don't know, but we just found Req to be 4/3. Okay, so if we divide both sides by 4/3, if I take my calculator here, and I've got 12 divided by parentheses 4/3, I get an answer of 9. So my total current here is 9 amps. All right. Now last but not least, calculate the current across the 4 ohm resistor. Now we could do this a bunch of different ways, but what I'm going to do is I'm going to zoom in here on my 4 ohm resistor. And I'm going to use the equation V equals IR, Ohm's law. So you notice how this is different than this one? This is just the voltage for the 4 ohm resistor, just the current for the 4 ohm resistor, and just the resistance of the 4 ohm resistor, okay? So I'm just looking at this particular piece. All right, so what's the voltage that goes through the 4 ohm resistor? Hopefully you're saying to yourself, hey, the voltage is the same in a parallel circuit, so it must be 12. The current, I don't know, and the resistance would be 4. Okay, so doing this complicated math, you should find that the current is 3 amps. All right, let's do one more here. I just gotta fix my paper. All right, we're gonna kick it up a notch. We'll see if you're ready. Now this one has a couple of questions too. First, it wants us to calculate the equivalent resistance. And then it wants us to find the current through R1 and the voltage across R3 and the value of R2. Now if you're looking at this here, the battery has a value of 24 volts. This ammeter is measuring 3 amps. R1 is 20 ohms. R2 is unknown. And R3 has a value of 30 ohms. Okay, so let's start at the beginning here and say, calculate the equivalent resistance. All right, so here I am in my parallel resistors. which equation can I use to solve for the equivalent resistance? Well, hopefully you're saying the bottom one, because we can't use the top one because we're missing the value of R2. Okay, so we're going to do this a little bit differently and start with this problem here, where we're going to say that VT equals IT times REQ. Okay, now the total voltage is 24. What's the total current? You're right, 3 amps. This ammeter here is measuring the total current, and we want to find REQ. Okay, so this, dividing out, we should find that 8 ohms is our REQ. And remember, REQ is going to be smaller than the smallest resistor. And right now, we're in business. Okay, so calculate the equivalent resistance. Done. Next, we want to find the current through R1. Okay, now up here, when we wanted to find the current through one particular piece, we did this, V equals IR, and again, just for that piece. Okay, so through R1, what's the voltage? Well, we know in a parallel circuit, the voltage is always the same. So in this case, the voltage is 24. We don't know what the current is, and we want to find the resistance. So if we take and we divide 24 by 20, we should get that the current is 1.2 amps. Okay, all right, done with that. The voltage across R3, well, this one's easy, right? What's the voltage across R3? Hopefully you're saying to yourself, remember, the voltage is the same. So in this case, the voltage is 24 volts across R3, R2, R1, and the total. That one was easy. All right, and now, how do we find the value of R2? This one is not so easy. What's the only equation that we can use that has an R2 in there? This middle one. So here we go. If we start with the equation 1 over REQ equals 1 over R1 plus 1 over R2 plus 1 over R3. Our REQ is 8, right? R1 is 20. R2 is unknown. And R3 is 30. Okay, so in order to solve this, I'm going to do 1/8 minus 1/20 minus 1/30 is going to equal 1 over R2. So let's get a number for that. Ready? So in my calculator, I'm going to do 1/8 minus 1/20 minus 1/30. Okay, and I get this ugly number here. So I'm going to say that this is 0.0417. Okay, so I get 0.0417 is equal to 1 over R2. Or that R2 is equal to 1 divided by 0.0417. Okay, so if I take, oh, I lost it. Okay, and then I do 1 divided by this answer, I get 24. Okay, so R2 is equal to 24 ohms. All right, that's all she wrote. Have a wonderful day, folks. Bye-bye.